Bismillahirrahmanirrahim. Today I'd like to talk about Euler's theorem as it relates to polyhedrons. Some students have a difficult time drawing these polyhedrons, so I thought I'd share with you how I do it. So let's say that you wanted to draw a square prism. First, I would draw a square. Like this. Kind of like a square. That would be the front base. And then I would draw another square, but slightly smaller than the first one, because it's going to be farther away. And then I would just connect these vertices like this. And there you have it. Now if you had a ruler, when you would be drawing this, you could draw these as dotted lines, like this. And that would give it an extra detail that would suggest that those lines are behind these other lines. So that's how I would draw a square prism. Now let's say you wanted to draw a triangular prism. Basically, I would do it the same way. I would draw the first triangle over here, which would be the first base. And then I would draw a smaller triangle like this. That would be the base that's in the back over there. And then I would just connect the vertices like this. Here I'm going to use the eraser to kind of make these into dotted lines like that. So there we have a triangular prism. Now Adjoint Pyramids also poses some difficulties for students. Let's say you wanted to draw a square pyramid. What I do is I first draw the base. Now this square is kind of laying flat on the ground, so it kind of looks like a parallelogram like this. Not the best, but as I say, perfection is the enemy of good. And then you would pick a point here for what would be the vertex, and then I just connect that vertex to all of these vertices over here. Perhaps I could do a little better over here like this, and then I could make these dotted lines to suggest that those are farther away and behind, like this. There we go. And we have a pyramid. Now if you wanted to draw the height like this, we could do, you'd take a line from there and kind of towards the center of the square over here. And that will be our square pyramid. And there we have it. So I've drawn for you over here what I thought was a square prism, a triangular prism, and a square pyramid. Now, Euler's theorem, as you recall, Euler is spelled Euler but pronounced Euler. Euler's theorem applies to polyhedrons. This is what it says. It states the number of faces plus the number of vertices minus the number of edges equals 2 in all polyhedrons. Again, the number of faces plus the number of vertices minus the number of edges equals 2. I just want to bring to attention this negative sign over here. It's f plus v minus e equals 2, where f is the number of faces, v is the number of vertices, and e is the number of edges in the polyhedron. To me, this kind of spells 5, right? Kind of like the 5 platonic solids or something like that. So, but this is a pretty easy theorem to remember, I think. F plus v minus e equals 2. So let's see if this applies to the polyhedrons that we've drawn over here. So let's count. Over here, the number of faces. Well, we have the 2 bases over here. That's 2. And then 3, 4, 5, 6. So the number of faces is 6 plus the number of vertices. That's 1, that's 2, that's 3, that's 4, that's 5, that's 6, that's 7, that's 8. So we have 8 vertices minus the number of edges. So let's count the edges. Okay, so here's 1, 2, 3, 4. You have to be very careful. You have to do some kind of organized fashion. So 5, 6, 7, 8. I got those. 9, 10, 11, and 12. That's 12. Now let's see. 6 plus 8 that's 14. All right, minus 12, and that indeed is 2. Ta-da! So that works. So I'm going to leave this triangular prism for you to do. But let's do this square pyramid. So the number of faces, okay, is one base. There we go. And that's 1. And then there are 4 triangular faces. That's 5. So the number of faces is 5. Plus the number of vertices. Okay, that's easy. That's 1. That's 2. That's 3. That's 4. That's 5. And that's 5. And then I have to subtract from it the number of edges. Okay, there's 1. There's 2. There's 3. And there's 4. Okay, and then there's 5, and there's a 6, there's 7, and that's 8. So that's 8 edges. So 5 plus 5 is 10 last I checked, and 10 minus 8 is 2, and that works. So to finish off, I like to do this question. This question says a polyhedron has 6 faces and 7 vertices. How many edges does it have? Well, we know that the number of faces plus vertices minus the number of edges must equal to 2. And we are given here that there are 6 faces and there are 7 vertices. And we can substitute that in our equation. And we simplify. That's 13 minus e is equal to 2. I subtract 13 from both sides. Like this. I get negative e equals negative 11. Divide both sides by negative 1, and you get e is equal to 11. This particular polyhedron will have 11 edges. I hope you enjoyed. Until next time, as-salatu was-salamu ala rasulillah walhamdulillahi rabbil alameen. Assalamu alaikum.